here we are. So, important concepts to get. Really critical things. All right, this is oxidation reduction. This is the food. The yellow is the food. We oxidize the food to get energy from it so we can get ATP in the big picture, right? That's the story. So here's the food. And what we're going to do is we're going to pull electrons off, right? See that? We take it off. And when we do that, the A becomes oxidized. The food becomes oxidized. And this little piece that's left over, that comes over here, that's reduced, this is going to be important in the future for generating ATP. Okay. Okay. Now let's go down. I'm going to go down and show you. And all of these reactions are like that. They're oxidation reduction reaction. What do we have? We are going to be transferring that very important energy from the food to this very strange, but B vitamin. It's a B vitamin, NAD. And so what NAD is going to do, it's going to pick that thing up, it's going to get it, it's going to carry it. All right? It's going to carry it all the way to the mitochondria, where it is going to be used to generate 36 to 38 ATPs. That's where it's going. Okay. And we just go through all this food, and basically what we're doing is we're taking the molecules and we're rearranging them so that we can have the energy in one spot, and then we can take it off, just like we did right there. Okay, that's it. They rearrange the reaction. So I'm going to go through them. And first, um, before we start, we got this one kind, and it's called substrate level phosphorylation. And all that is we take that high energy that we just took from the food, and that's going to be in the form of a phosphate bond right here. The third phosphate bond, ATP. We add with this would be ADP, but then we add this high energy phosphate that comes from that molecule that we were working on. Okay. And we do this right here. Just do a substrate level phosphorylation, just transfer the phosphorus right on over, and there we are. Okay, and that's what it is. Boom, that's how that goes down. All right, now, when we do oxidative phosphorylation, this is different. This is going to take us all, we're going to have carriers, these two B vitamin carriers, they're going to be carrying this, and we're going to go all the way to the mitochondria, right? We're going to take it on the mitochondria into the inner membrane of the mitochondria and finish up there. But it can't just get there by itself. It has to be carried. And that's what these guys do, these NADs. And if you're not getting your B vitamins, you know how you feel. Do you know B12? Have you ever tried that? And those energy drinks, there's caffeine in it, yeah, and there's sugar in it too. But the B12, oh my goodness, so much energy. Just take one of those. If you feel down, take it. It's amazing how much. And it all has to do with just making these reactions work out better. You're just making sure that your body has what it needs to do this. Okay, so one thing that's going to happen is we got this electron transport chain. So we have these electrons. We've taken the electrons off the food. We passed it on to the NAD and the FAD. Okay. And we come on down with inner membrane of the mitochondria, and look at that sucker. There they are. So we got the NADH, and now it's NAD plus, back where it was. FADH, and it's back to FAD. And these electrons are just going to roll along down here as they go from one to the next to the next. Now, as this happens, we are going to do something odd. I'm going to talk about it now. We'll talk about it again later. As these go through and they're being passed down, we're going to make water. We're going to use oxygen because this is oxidative phosphorylation, not anaerobic. Okay, so we do that, and while they're flowing down, every step along the way, an H plus is going to be thrown out over here. Okay, it's going to be taken from this side and it's going to go through to the other side. Each time we go through here, we're going to throw an H plus out here, and there'll be one less H plus on this side as we do this. See that? We're going to go all the way down all this. And so with a lot more H plus, as you know, that would mean the pH would be lower, right? More OH makes the pH higher, more H plus makes the pH lower. So there'll be a lot more H plus and a lower pH here than on the other side of the membrane. So basically, you have established a gradient, okay? And then we're going to use that gradient to generate energy, much like with a dam. Like a dam. We make the dam, we store the water behind the dam, right? It fills up, and then we let it out when we need it to make energy. And that's what you got here. Is exactly what's going on. We have potential energy that we have set up to do the kinetic energy and make the ATPs.